My name is Samia Burbano, and I'm going to talk about one of the most important inventions nobody has heard of. In this opportunity, I'm going to introduce you to self-healing concrete. I will go over a small background from this research. I'm going to tell you what is this about, how does it work, the importance that this contribution has in our future civilization development, the issues it still has to overcome, and what we can conclude from it. Research about self-healing concrete started in 2006 under Dr. Henk Jonkers, a microbiologist at the Delft Technical University in the Netherlands. It became a case study influenced by the search of its materials. This research was conducted alongside with the Civil Engineering and Geosciences faculty. What is it about? This invention consists of a bacteria embedded on concrete mixture that acts as a healing agent as it converts its nutrients into limestone to seal up the cracks. It resembles how the human body regenerates new bone material after it has suffered a fracture. How does it work? There are two main components that allow this self-healing process of concrete: the bacterial spore sands and its nutrient, the calcium lactate. The bacteria that was needed for this project has a special quality since cement and water mixed together have an extreme alkaline environment in which most organisms wouldn't survive. So an alkaline environment was needed for the extraction of such bacteria and was found on the Russian soda lakes. The calcium lactate was found to be what the bacteria fed on, which as well is a primary component of limestone and will allow for the self-healing process. Initially, the two main components are located in separate pellets in the concrete, so the process is not activated until needed. So how does this process actually work? As we can see here in the schematic, when a crack forms in a concrete structure, water seeps through it, allowing the bacteria and the calcium to be in contact with each other. The bacteria germinate and feed on the calcium, and as it does, oxygen is consumed and the soluble calcium lactate becomes insoluble limestone that fills up the crack. As well, the oxygen being consumed helps to mitigate the corrosion in the steel reinforcements inside the concrete, increasing its durability. Here's a video example that shows proof of the self-healing concrete.
Here we see an example of a piece of cracked concrete. You can see the crack and even a big hole. Here you can see that the bacteria have closed the crack and even the big hole completely filled with calcium carbonate.
Why is this innovation important? Concrete is and will be one of the main materials used in construction industry, and its durability becomes imminent. Traditional concrete tend to crack when subjected to tension. That is why it is reinforced with steel to withstand tensile forces. However, this steel reinforcement is affected since structures in contact with water become vulnerable to corrosion, which reduces the lifespan of the structure and compromises its safety. As well, we can all agree that repairing damaged structures are time-consuming and expensive, and in many cases is very difficult since the location of cracked structure is not of easy access. Although this invention has a positive impact, it is still in development and therefore has flaws. The strength of the concrete is reduced due to the new pellets that hold the healing agent and occupy 20% of the volume that will normally be filled with harder aggregates such as gravel. The cost doubles that of traditional concrete. This is mainly because the calcium lactate is expensive, and as well it is the process of embedding the bacteria and the calcium into the pellets since it involves a special vacuum technique. However, many steps toward the solution of these issues have been taken and are under studies. The Dutch government as well as some industry companies have funded more research towards its optimization. We can all agree that this invention is very important since it will increase the lifespan and safety of infrastructure that normally surrounds us everywhere. Even though right now it is expensive material, in some applications where safety is important or access is difficult, a large lifespan will be more economy efficient in the long run. As well, in a more close home experience, we might be able to avoid construction season and have an actual summer season. Thank you for watching.